continuing on with angles, we're going to be talking about the angle addition postulate. Before that, let's review naming. Look at this problem below. There are 3 angles in the diagram below. Why can't any of the angles be named angle X? So take a second to pause before you continue the video. Okay. Now notice there are 3 angles here. Okay, we have this angle right here. So I'm going to go ahead and make this angle red. Okay. And we have here also the top angle. So I'm going to make this blue. Notice that they share the same side. Now the ray of an angle, we call it a side. So they share this side, which is ray XY. Okay, we'll talk about the third angle here in just a second, but let's take a look at these 2 angles, okay, that happen to have the same vertex. So if I say, what's the measurement of angle X, you won't know which angle I am referring to. For example, let's say you are in school. Now, if in school you had just, let's say, in school there's just one person named Albert, then I'm going to call that young boy, I'm going to call him by his name, Albert. But then, let's say the next year in the same class, I get another young boy named Albert in the same class. And let's say I get another person. Sometimes it happens. I've had two Chris's, actually 3 Chris's before. And then there is another Albert. I can't just say, Albert, tell me the answer to question blah, blah, blah. Because then neither the Alberts will know which Albert I'm referring to. So I can call this one then Albert S for his last name. I can call this guy here Albert P because his last name starts with P. And I can call this third Albert R. And so when I say Albert R, tell me the answer, we all know which Albert we are speaking about. Now, I'm going to make sure that Albert is the starting point, right? Your name starts with your first name, and then you can have middle name, last name. So I'm not going to just say, okay, from now on, you're not Albert, you're called Sam, and you are called Cole. I'm not going to change their names. They will hate me as their teacher. So I still have to call them by have to have their name, their first name, their starting point somewhere there. But then I need to add something else that will allow me to tell apart which Alberts I am talking about. So again, if it was just one Albert in my class, I can just call him Albert, just Albert, or angle A, not angle BAC or whatever other points I used to get. In the same case we have here, we have more than one angle here, and I'm not going to call it, I'm not going to call any of those angle X. So let's start with the red angle. And remember, color is not a correct terminology, a correct mathematical name. So we have to use the naming. So let this red angle can be called angle YXZ or angle, so I can go the other direction starting with this bottom side, ZXY. Just like when I called the Alberts, I still had to call them Albert plus their last name initial. Same thing, whatever way, direction you name it, you still have to include the vertex in the middle. Now let's take a look at the top angle. And again, I have here, I'm not going to call it the green angle, okay? That's not a good name for it. We're going to call it angle W. This is a point on one side. X, which is the vertex, and Y, the point on the other side. And I can go the other direction, Y, X, W. Now this right here probably throw some people off. The 3 angles. You may stop this video, think about it, or you can continue if you know. These 2 angles together, they share this one side, create a bigger angle. Just like, for example, if I have the length of my head plus the length of my torso plus the length of my legs, I have the full length of my body. In the same case here. So this is angle. The third angle we're seeing here is ZXY. Or pardon my little, or WXZ. I'm going to say ZXW, or WXZ. So now we have named the answers. Now I just alluded to the fact of Angle Addition Postulate. Postulate is another word for a rule. It says here in words, if the point P is in the interior of angle RST, then the measure of angle RST is equal to the sum of the measures of angle RSP and angle PST. Now, how do we say this in symbols? Okay, well, again, in symbols, you could say it as, or write it as, if P, this refers to point P, uppercase P, is in the interior of angle RST, then the measure of angle RST is equal to the measure of angle RSP plus angle PST. Now here is the visual, but let's actually do it together. Let's put it together and make this postulate come to life. So first, let's actually draw angle RST. So if you notice, S is in the middle, so that's the vertex. So I have angle R and point R and point T here. So this is going to be the point on one ray on this side of the angle, and this is a point on the other side of the angle, angle RST. Now it says here, if P is in the interior, if P is in the interior, and the interior means that any point between the 2 sides of an angle is in the interior. So I'm going to draw one point. I could put here, I could put it here, I could put it here. It doesn't matter as long as that point is inside, meaning interior and side. So between the 2 sides of the angle. A point here would be in the exterior, so it wouldn't count. So any point. So I'm just going to put this here. I'm going to call it point P. So what is that telling me? If P is in the interior of angle RST, then the measure of angle RST is equal to the sum of angle RSP. So let's go ahead and do that. Angle RSP. RSP. So it's measure. That represents the measure. And if we add the measure of RSP with the measure of angle PST, so they're both sharing the same P that we're talking about, this point in the interior of the larger angle RST. So now we're going to go ahead and I'm going to just visualize the second angle here, PST. So if I were to sum or add the measure angle RSP to the measure of angle PST, then it will equal the measure of angle RST, the measure of this black.